Welcome! Today, we'll explore exponential equations. An exponential equation is simply an equation where the variable you're trying to solve for appears in the exponent or as a power of a number or expression. Let's look at a few examples to make this clear. First, 2 raised to the power of x equals 16. Here, x is the exponent. Second, 3 raised to the power of x plus 1 equals 27. Again, the variable x is part of the exponent. Third, 5 raised to the power of 2x equals 125. Fourth, e raised to the power of x equals 7. E is the natural exponential base. And fifth, 10 raised to the power of 2 minus x equals 100. Now, how do we solve these? The first strategy is used when you can make the bases on both sides of the equation the same. If the bases are the same, then the exponents must be equal. Let's take our first example. 2 to the x equals 16. We know that 16 is the same as 2 raised to the power of 4. So, we can rewrite the equation as 2 to the x equals 2 to the 4th. Since the bases, which are both 2, are the same, we can simply set the exponents equal x equals 4. What if the bases are different and can't easily be made the same? In this case, we use logarithms. Consider the equation 3 to the x equals 20. We can't easily write 20 as a power of 3. So, we take the logarithm of both sides. You can use any base for the logarithm, but base 10 log or the natural logarithm ln are common. Let's use base 10 log. We get log of 3 to the x equals log of 20. Using a logarithm property, the exponent x can come down in front x times log 3 equals log 20. Finally, to solve for x, we divide both sides by log 3. So, x equals log 20 divided by log 3. Sometimes both sides of the equation involve exponents. Again, the first thing to try is to get the same base. Let's look at 5 raised to the power of 2x equals 125. We recognize that 125 is 5 cubed, or 5 to the power of 3. So, the equation becomes 5 to the 2x equals 5 to the 3. Since the bases are both 5, we equate the exponents. 2x equals 3. Solving for x, we divide by 2, giving x equals 3 halves, or 1.5. A special case involves the natural exponential base, e. When e is involved, we typically use the natural logarithm, written as ln, which is log base e. Consider e to the x equals 7. To solve for x, we take the natural logarithm of both sides. Ln of e to the x equals ln of 7. A key property is that ln of e to the x is simply x. Therefore, x equals the natural logarithm of 7. Let's quickly summarize the key steps for solving exponential equations. First, try to rewrite the equation so both sides have the same base. If you can get the same base, set the exponents equal to each other. If you cannot get the same base, use logarithms log base 10 or natural log ln on both sides. Finally, solve the resulting equation for the variable. That's the basics of solving exponential equations. If you'd like to work through some practice problems or have a specific equation in mind, feel free to ask. In this video, we'll solve an exponential equation that can be reduced to a quadratic form. The problem asks us to solve the equation 3 times 2 to the power of 2x plus 1 minus 11 times 2 to the power of x plus 3 equals 0. We need to give our answers correct to 2 decimal places. Step 1. Let's simplify the first term. 3 times 2 to the power of 2x plus 1. We can use the exponent rule that says a to the power of m plus n equals a to the power of m times a to the power of n. Applying this, 2 to the power of 2x plus 1 becomes 2 to the power of 2x times 2 to the power of 1, which is just 2. Next, we use another exponent rule. A to the power of mn equals a to the power of m raised to the power of n. So, 2 to the power of 2x can be written as 2 to the power of x squared. Combining these simplifications, the first term 3 times 2 to the power of 2x plus 1 becomes 3 times 2 times 2 to the power of x squared, which simplifies to 6 times 2 to the power of x squared. Now, let's substitute this back into our original equation. The equation becomes 6 times 2 to the power of x squared minus 11 times 2 to the power of x plus 3 equals 0. Step 2. This equation looks like a quadratic equation. To make it clearer, let's use a substitution. Let y equal 2 to the power of x. Substituting y into our simplified equation, we get 6y squared minus 11y plus 3 equals 0. This is a standard quadratic equation in terms of y. Step 3. Solve the quadratic equation for y. We can use the quadratic formula. Y equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. In our equation, a equals 6, b equals negative 11, and c equals 3. Let's substitute these values into the formula. Y equals negative 11 plus or minus the square root of negative 11 squared minus 4 times 6 times 3, all divided by 2 times 6. Simplifying this, we get y equals 11 plus or minus the square root of 121 minus 72, all divided by 12. Further simplification gives y equals 11 plus or minus the square root of 49, all divided by 12. Since the square root of 49 is 7, we have y equals 11 plus or minus 7, all divided by 12. This gives us two possible values for y. First, y1 equals 11 plus 7 divided by 12, which is 18 divided by 12, or 1.5. Second, y2 equals 11 minus 7 divided by 12, which is 4 divided by 12, or 1/3, which is approximately 0.333. Step 4. Now we need to find the values of x. Remember our substitution was y equals 2 to the power of x. First, let's use y1 equals 1.5. So, 2 to the power of x equals 1.5. To solve for x, we take the logarithm base 2 of both sides. So, x equals log base 2 of 1.5. We can calculate this using the change of base formula. X equals the natural logarithm of 1.5 divided by the natural logarithm of 2. Plugging this into a calculator, we get x is approximately 0.58496. Rounding to 2 decimal places, x is approximately 0.58. Now let's use y2 equals 1/3. So, 2 to the power of x equals 1/3. Again, we take the logarithm base 2 of both sides. So, x equals log base 2 of 1/3. Using the change of base formula, x equals the natural logarithm of 1/3 divided by the natural logarithm of 2. Calculating this, we get x is approximately negative 1.58496. Rounding to 2 decimal places, x is approximately negative 1.58. So, the solutions to the equation 3 times 2 to the power of 2x plus 1 minus 11 times 2 to the power of x plus 3 equals 0, correct to 2 decimal places. Our x is approximately 0.58, and x is approximately negative 1.58.